Hey, welcome to today's lesson. Today we're going to learn how to solve rational inequalities. Now, the other day we learned how to do polynomial inequalities, and remember that this inequality less than or greater than kind of causes an issue for us when we're trying to solve it. So what we ended up doing to tackle that issue is we ended up making a sign chart. And on the sign chart are significant points that determined the different regions we would test came from the roots. Well, with rational inequalities, we're also going to do a sign chart, but we have some other factors that are going to show up that determine where our regions are within that sign chart. So feel free to pause the video as much as you need to. Take notes on your own. We're only going to work through 2 problems today, so pause the video as needed. So the first thing we're going to do as we prepare to set up our sign chart is we're going to find all the critical points, and we're going to use these points in our number line. Now when I say critical points, these are going to include the x values of the roots as well as any holes or vertical asymptotes. So first of all, I jumped ahead by misclicking that number, but you see that we do have a hole here because the x plus 1 over x plus 1 is just a giant 1. So when we look at our roots, we have a root at 3 and a root at -2. We have a hole at -1. And the final thing that I really care about would be the vertical asymptotes. And so we have vertical asymptotes at an x of -3 and an x value of 2. Now, I don't really care about horizontal asymptotes. Those aren't really going to affect me solving this inequality. It's the vertical ones and the holes that I really care about, because a horizontal asymptote really kind of affects more of the y values than it does affect the x values. And we're solving this for x. So those are my significant values. So next, we're going to set up a sign chart using the values from step 1, the roots, the holes, and the vertical asymptotes, and the factors from the simplified expression. Pay really close attention to the holes and the asymptotes versus the roots. We want to make sure we know what's a root versus what's a hole or an asymptote. So let's set this thing up. There is my equation. I just rewrote it down here so we have it. And let's set up that sign chart. So first of all, if you recall, I'll go back up here, we had a root at 3 and another root at -2. Those are here. And since we're allowed to equal 0, I want those roots to be solid circles. Now we have hole at -1, a vertical asymptote at -3, and another vertical asymptote at 2. And since the values, the graph doesn't actually exist at holes or at asymptotes, I want those to be open circles, since x really cannot be where a vertical asymptote or a hole exists. And when I go to set up the rest of my sign chart here, I'm going to want these 4 factors to show up in the sides, and I'm going to use the asymptotes and the roots and the holes to form my regions. And I have plenty of regions to check. So here we are. We're all set up here. Let's start testing numbers. I'm going to choose a number that is smaller than -3, like, negative a gajillion. And when I do that, it turns out that each one of these factors is a negative. And a negative times a negative divided by a negative divided by a negative, all those negatives create a positive. So I know that I'm going to be above the x-axis for this region here. Picking a number between -2 and -3, maybe I choose -2.5. When I put a -2.5 into this factor, this factor, this factor, and that factor, I end up with these signs, all negatives except this one here. And when you multiply or divide this many negatives and a positive, you end up with a negative. And again, I'm going to go through and test numbers in each of these regions to see if they yield a positive or a negative. And I'm going to mark up here on my number line whether the graph is above, meaning a positive output, or below, meaning a negative output. And this is what I end up getting. And when I go up here and I look at what type of answers I want the outputs that are bigger than or equal to 0. So bigger than or equal to 0, those are positive outputs. And here, right here, I have positive outputs, and that is from negative infinity to negative 3, parenthesis. These outputs are negative. I don't want them. From negative 2, including negative 2, up to, but not including 1, I want that. From negative 1 up to, but not including 2, I want that. And finally, I have a positive region out here, which is bigger than 3 and including 3. And this whole thing down here would be my answer. And if we graphed this expression, if I graphed this rational expression, y equals the quantity of x plus 1 times the quantity of x minus 3 times the quantity of x plus 2, all over this. If I graphed it, my graph would look like this. And if we look at where our graph is bigger than 0, where this graph is above the x-axis, you see it's above the x-axis here, which is from negative infinity all the way up to right there, which is negative 3. That's that part. You could see that we are above the x-axis right here at 2, up to, going all the way up to 2. So from negative 2 all the way up to 2, but not including 2, we're above the x-axis except for this hole. And that hole was at negative 1. So you see this part is handled here in purple. And then finally, we're above the x-axis from right there forever. It's always getting bigger, but it's never going to cross 1. And that part is here. So, I mean, if we knew what the graph looked like, we could just go from the graph. But I don't think any of us knew what this graph looked like. That's why a sign chart is so important. Well, let's try one more. Okay, so let's take a look at this. We're going to solve this function right here. And the first thing we can do is we can factor the denominator. And then we want to identify the critical points. The first critical point we probably want to identify would be the root. And you can see we have a root of 1/2. There aren't any holes, but there are 2 vertical asymptotes at negative 2 and negative 4. So these 3 values are going to go down here in my number line. They're the critical points. And let's see here. Our output is allowed to equal 0, so the root should be solid. But these asymptotes, x cannot cross an asymptote, so those are going to be open circles. And now we have, it seems like 4 regions. We have these 3 factors which go down here. And then we do our test. This would be a good time for you to pause the video, run your tests in each one of those 4 regions and see what your output is, and finish up this problem on your own. So I'm going to put my faith in the fact that you're actually going to pause the video and try this out. Hey, welcome back. I hope you paused the video. Anyways, here's what we have. When we test a number in this region, we end up getting 3 negatives, which ends up giving me a negative. And of course, if the output is negative, we're going to be below the x-axis. When I test a number in this region, I end up getting 2 negatives and a positive. And when you multiply and divide those, you end up with a positive, which puts you above. Here, below. Here, above. And it looks like, based on this, it looks like the output I want are the output should be below 0, should be negative. I'm looking for that negative output. And we have a negative output here from negative infinity up to, but not including negative 4. We also have a negative output here, so I'm going to have a union from negative 2 up to and including 1/2. And again, if we knew what this graph looked like, and the graph happens to look like this, we can see where this graph is producing values that are below 0, that are below the x-axis. And according to this graph, that happens from negative infinity all the way up to right here, -4. That's the green part. And we're producing values below 0 from -2 all the way up right until we hit the x-axis, and that looks to be at 1/2. That's the purple part. So again, if we knew what the graph looked like, we could just go right off the graph. But I doubt any of us knew what that graph looked like. So that's your lesson for today. Why don't you go ahead and give the homework a try? Do the best you can. I've got a problem or two in there that's a little tricky, but you're a smart person. You can figure it out. Good luck.